I'd like to welcome you all here to this presentation this afternoon, and thank you for attending. The topic today is GoodbyePaper, and we're going to be talking about paper, a little bit about its history and everything that it's done for us. And I'm looking forward to speaking with you guys. And we're gonna have some time at the end for questions. So stick around if you have any questions about the presentation or whatever. All right. So, a little respect, please. Paper has been around for a very long time. In fact, we've been using paper for hundreds of years to build all kinds of things. But of course, our focus here today is shipbuilding, and you can see on the screen that we have a kind of a nice picture, a nice drawing of the Bounty, showing its hull, a little bit of its hull and its internals. And so we've been using paper for hundreds of years to design ships. And it used to be that we could fit a full design of a ship onto a half dozen big A0 size sheets of paper. Of course, things are a little bit more complicated now. But if you think, back in the before the 15 and 1600s, we had before we started committing things to paper, we had ship constructors who actually were shipbuilders who had all of this expertise and knowledge in their heads, and we would use their expertise to actually build the ships. There was nothing committed to paper; everything was in their head. And then with the kind of the birth of the scientific revolution, we got to the place where we started to think about planning ahead. So it was the beginning of being able to build things virtually first. But back in the 16 and 1700s, as you guys know, Europe was, one country was at war with another. It was England against France. It was the Netherlands against Spain. It was, well, maybe not those guys, because I think that there's some colonialism going on in there. But most of Europe was at war with each other at one point or another. And navies were a big deal then. I mean, naval power was, Britannia rules the waves, and naval power was a big deal. So creating these the bigger the navy and the faster the ships and the more robust the ships, the more likely you were to win these wars. So really, war was driving them, the European shipbuilders, to build better ships faster, and they were utilizing this fancy new technology called paper to write down and capture all of their technical ideas before committing them to wood at the time. Yeah. So the first ships built from paper still relied. I mean, like I mentioned in the last slide, a lot of the knowledge was still in the ship constructor's head, right? So really, it only took again, like maybe a half dozen drawings or maybe a dozen drawings, and that was the entire build, right, captured right there. So it really relied on the expertise of the shipbuilders, the shipwrights, right? The guys on the, well, I guess it was a build yard then. It wasn't so much a shop floor, But their expertise and the main ship constructor worked with the drawings, and really the drawings were almost a guide, you know what I mean? And so it's so even a complicated warship, built back then could be done with a half dozen or a dozen drawings. And but oh my, how things have changed, right? I mean, you guys know that now it's tens of thousands of drawings. A couple of years ago, I attended the SNAMI conference in Tacoma, Washington, and Mark DeBink gave a presentation on some things that were going on as far as, I think the topic was the digital twin, and he was talking about how Newport News was becoming a digital shipyard. And one of the things that he mentioned was how many hours had gone into the design of the new Ford-class aircraft carriers, and it's over 50 million hours. And I couldn't believe it when he said the number. I think, and I'm sure I wasn't the only one who was like, did he just say 50 million? Yeah. I mean, we're talking about years and years and thousands of people committing time And you can imagine how much paper was generated in this, 50 million hours of design work. So we're talking tens of thousands of drawings and documents, individual documents. So how has paper done it? How has paper been able to stick around for so long when we've had computers for decades, and we have all this fancy software, 3D software. We evolved from 2D CAD that kind of was just more like drafting. Instead of using paper, we were using, like AutoCAD, for example, or MicroStation. And that's evolved into, complex 3D modeling. Yet paper somehow has still managed to hang on, right? So, I mean, there's advantages to paper, obviously. So let's talk about them for a second. So first of all, paper is inexpensive. It doesn't really cost very much to take to take your CAD drawing and turn it into a piece of paper for the shop floor. I mean, and even paper in general is relatively inexpensive, as you know. It's pretty robust. I mean, we can be up on a scaffold on the shop floor, drop the paper, and nothing happens to the paper. Basically, we can go back down to the shop floor, pick up the paper, and it still works absolutely perfectly. Nothing wrong with it. It's more or less accurate. I have some issues with the accuracy of paper, but we can talk about that another time. Turns out line thicknesses matter, as you know. Paper's mobile. It's easy to copy. It's great for taking notes. And again, there's issues there as well, wrestling paper back from guys on the shop floor who have all these notes written on them. So, I mean, paper has, it has staying power because it's really, I mean, it's quite good. But I'd also like for us to think about it in these terms as well, that paper was really when design work is really building the thing first before you build the physical asset. Before we build a house, before we build a building or a car. I mean, we work out all the details on the virtual prototype first, and paper has been a really faithful companion as far as the virtual prototype goes. But we're at the place now where our new tools, our 3D tools, really are getting ready to I think replace paper as the go-to medium for building things virtually. So we stopped kind of using paper as the main design tool probably 30 years ago. And so at first we were using kind of computers to replace the drafting board, and they literally just became 2D drafting boards, but digital drafting boards where we could create all of these great 2D drawings. And the paradigm of 2D kind of made its way into CAD. And then, even back when I started using AutoCAD, right back when I was in university, even then we were starting to play around with things like 3D Studio and 3D modeling, and we could see that eventually we'd get to the place where we were 3D modeling things and beginning to build and you could see how the thought process could evolve into the 3D model and becoming the 3D prototype or the virtual prototype, right? And but even still, even though we could, building all these complicated models, we still are in the place where, and we have been where we still have to, from this 3D model, we're still creating all of this. We're translating it from the, our wonderfully created 3D models, translating into all this 2D, data for the shop floor, right? And we lose something in that translation, right? We have this robust, complex 3D model that captures so much of the build digitally, and then we have to stop, slice everything up, and make sure that the guys on the shop floor can have all these individual pieces of paper. And like I mentioned earlier, we're talking tens of thousands of drawings. And so, we lose something in the translation, right? Wouldn't it be great if, the guys on the shop floor could actually, look at the 3D model rather than look at a kind of a dead piece of paper. But of course, we have done this intermediate step, right? It's not that there's just paper. But of course, what we've done is created this digital representation of paper. And so I can remember back in the 90s when the PDF first came out, I can remember thinking to myself, what is this for? Why do we need this? I mean, we have the original files. We have a drawing file. We have we have our WordPerfect files. We have all these things. Why do we need a PDF? But, I think Adobe it was a stroke of genius here, because anybody could download a reader. We could look at drawings in the reader, and tools evolved to help us even redline drawings. I mean, I'm thinking, and we're still doing that even now. So, as computers, and I think this came out of the idea that as computers began to become connected, instead of having to be in New York, for example, where your engineering office is, and send this tube of paper to Seattle or to Vancouver, we could just email the files, right? And if the person on the other end didn't have the CAD software that we had, they could certainly open up a PDF and have the tools to kind of redline or at least review. And so the PDF has become actually really important. But it's still really just a kind of a 2D representation of a 3D object. And I believe that we're still losing things in the translation. I mean, you guys know, no matter what part of the business that you're in, when you have to move data from one piece of software to another piece of software, you lose things in the translation. And that's true for lots of things, and not just moving data from one piece of software to another. From when we're translating anything from one medium to another medium, you definitely lose something in the translation. Translations aren't perfect, and that's exactly the same when it comes to taking a complex 3D model and trying to turn it into 2D documentation to build from. We're certainly losing things in the translation. So with PDFs, I mean, we have almost all the same problems. I mean, the PDFs have been great, but we have a lot of the same problems that we've always had with 2D, and that's we've just made our 2D drawings digital, right? So it doesn't eliminate all the problems. It just makes them easier to redline and to move back and forth. But they're still 2D, so that loss of something, that translation still had to go from 3D to 2D, and we've still lost that little bit, right? So it's a good first step, but of course, we need more. Ships are more complex, becoming more complex, so we need even a little more. So what's the problem? So as good as paper is, I mean, it has limits, obviously, and I've talked about some of them, but obviously they're 2D. They're static, and this is an important point, that the static nature of it means that it's a snapshot of history, right? And we know that we start building a ship. The physical build starts when the detailed design phase, or the digital build, is about 30% complete, or maybe less, right? So we know that there's changes, right? We know that the model is constantly changing. Everything is being updated and changed, and but these drawings are static, so that means that when the model changes, or when the design changes, it means that we have to go back, gather up all these drawings that are no longer the source of truth, and get rid of them. And sometimes you have to wrestle with the guys on the shop floor, because they've got so many notes on them, and they're stuck onto a bulkhead and taped on, and they really don't want to lose them. But we really, so document control, there's issues there. And there's a time delay. That translation from 3D to 2D takes weeks. It's pretty easy to create a single drawing, but we're talking tens of thousands of drawings. So there's this time delay to translate every single piece from the 3D model into the 2D representation of the 3D object, right? So yeah, so there's lots of reasons why paper it does absolutely have limitations. We're building these very complex ships virtually, and we're expecting paper to step up to the plate and go, yeah, I can still do everything. And it turns out that it can't. We're getting to the place where we have to say goodbye to paper. And, as sad as that is, I mean, paper is not going to go away completely ever, I don't think. But it just can't keep pace, right, with the complexity, the connectivity that we demand, right? We want the shop floor to be able to talk to engineering right away. We want things to be automated. We want to automate and update our MRP and our ERP and our project management systems, in real time. And we want reports to reflect exactly what's going on now. We don't want them to be, 2 days old, 3 days old. We want things right here right now, right? And so what's the solution? Well, to start with, we can't lose anything, any of the good stuff that paper's done for us, right? So, any solution would have to capture everything that a 2D drawing would. So we'd have to be able to isolate views of interest. We have to be able to zoom in on, we don't want a guy on the shop floor to have this giant 3D model of complexity where you have to kind of dig your way through the entire thing to find what you need. No, we need to be able to isolate quickly the parts that, and of course the 2D drawing is perfect because we can just find the drawing that we need, and it's isolated this, panel with stiffeners on it and some penetrations or whatever. And so that's become quite useful. And so it would need to do that. Obviously, we need to be able to have dimensions for construction purposes. We need to still be able to capture all of these things. But what else? So other must-haves are probably, the obvious one is it needs to save us time. Otherwise, what's the point? So whatever system that we develop, as we, begin to move away from 2D drawings and into 3D manufacturing information, or 3D MI, of course, it needs to save time. It needs to be mobile as well. I've heard of some companies who have like a computer station on the shop floor. So if somebody's looking at a paper and they need a little bit more information, they can wander over to the workstation and they can actually look at the model in that area, which is a nice kind of intermediate step. But I think that we have mobile devices now, so I think that whatever solution we have really needs to be on a tablet, needs to be easy to use. It needs to be able to work offline. It needs to close the loop between the shop floor and all of the systems that support the shop floor, all the business systems, engineering systems, project management systems. And it obviously needs to be secure as well. So not everybody can get at everything. And also we can't have it so that, somebody's sitting in a van outside the shipyard, sucking in all of this information that's floating around in the air. So it obviously, if we're working on secure things like naval vessels, we need to have that high level of security. And I think that we can have all those things, right? And then of course we can add all the things that make the digital prototype, that take advantage of the digital prototype rather. And of course, we can identify where in the ship things are. Like we have context, right? So the thing is if you, we were joking about this the other day, but if you turn over a piece of paper, you just get the back side of the paper. You don't get the other side of the panel, right? So we need to be able to have context. We need to be able to see where this thing is in the assembly sequence and what's around it, like where penetrations are coming through. And it definitely would help with the build. Dynamic checklists, feedback. We need to be able to take notes and send those notes off to again the supporting business systems like engineering, and this whole thing can be part of the digital thread as well, right? Because we're getting to the place where we're thinking about the PLM and the lifetime of the asset and all of the things that go along with that the digital twin / digital thread. So one of the tools that has been developed to support this paradigm that I'm talking about is Smartshape. And Smartshape is for mobile visual collaboration. It's designed really for visual work instructions, for 3D manufacturing information. And it's really designed for really big projects, right? So, and that's part of the issue is ships are some of the biggest things built by man. And the tools that we use to build these ships have to be robust enough to be able to handle so much data. And of course, Smartshape is designed specifically for this purpose. And you can see here we have a screenshot from a tablet. Really, Smartshape is web based, so it's mobile. It's visual. Obviously, we're looking at a screenshot here, and in this particular shot, you can see several compartments in a ship. In this case, the various profiles have different colors. Of course, you can configure it almost any way you want. However, your shop floor wants to look at their manufacturing information, Smartshape can be configured to give them that, right? But Smartshape is not just about seeing things, right? It's also about the data that's generated on the shop floor. As equipment is installed, you can identify that this is installed, it's tested, it's working, and all of that data is immediately fed back into the MRP and project management systems, the business support systems. So I mean, who else is doing this? And I like looking at other industries to see who is really kind of pushing the boundaries. And whenever I do, I always kind of switch over to the or I have a look at the aerospace industry, because they seem to be about 10 years ahead of us all the time. And sure enough, when I was looking at aerospace, Airbus in particular, I looked at several videos of them manufacturing this, and of course, what was on the shop floor, very little paper on the shop floor. It was all about visual work instructions on tablets, and it actually showed some of the work that was being done, and it was basically just tablets on the shop floor. Automotive, the automotive industry has been doing this for a long time as well. There are screens everywhere, not much in the way of paper anymore. So, other industries are evolving their way out of paper as well. And so, you might say, well, those guys, they're building the same thing over and over. We always have these one-off ships that we have to create. But I mean, there are shipyards that are doing this too. So Newport News, for example, they're eliminating drawings and, in their words, moving towards a model-based enterprise with an integrated shipbuilding environment. So basically, integrated for those guys means that their shop floor and their construction side is, again, really tightly connected with all their supporting business systems. So in their words, again, they have what they call visual work instructions. I like to think of it as 3D MI or 3D manufacturing information. And so you might say, well, I mean, Navy, deep pockets, and certainly, there's we know that the U.S. Navy has a fair amount of money to spend on projects, and they do. But of course, we have commercial shipbuilders using it too. Like, for example, on this slide, we have Chantiers d'Atlantique, and they're using Smartshape. And the slides in a couple of slides ago where I was showing you screenshots of a build in progress, those came from Chantiers d'Atlantique, and these guys have been having just great success with Smartshape and moving away from paper drawings and more towards an integrated shipbuilding environment for sure. So what does all this mean for Canadian shipbuilding? Well, with the NSS, we have this opportunity now. I mean, if you look at like Europe, for example, if you look at Germany and the Scandinavian countries, for example, in France, obviously, I mean, they're building ships, and they have been for decades. They continue to build ships, and they have a similar cost to build as we do. There's no reason why we can't continue to build ships here in Canada, even after the NSS has kind of folded up and finished up. But I really think that we need to look at building up some competitive advantage, and one of the ways that we can do that is by turning our shipyards into kind of modern manufacturing facilities with digital throughout. So, that's the end of my presentation, and I'd like to say thank you for listening, and really appreciate your attention and the fact that you came out to have a listen. And so we're going to take a few minutes now to, before we do that, I wanted to say too that if you wanted to learn more about Smartshape, you're certainly welcome to go to our website, and that's innovamarine.com. It's up on the screen. Or you can talk to David over at our booth, or myself, or Will, or any of the guys, and we'd be certainly happy to talk to you about Smartshape, mobile visual collaboration, 3D MI, visual work instructions, however you want to put it. We're happy to talk about it. In fact, we're excited to talk about it. So yeah, so now we have an opportunity for some questions, and I think we're going to open up the floor for that now.